Hi friends. So today let us see how a 4-point DIT FFT graphs look like. So we have a 4-point DIT, which is decimation in time, fast Fourier transform graph. Now we are having decimation in time. That means I'm going to break or divide my time. That means if I have an x of n signal, because it's a 4-point, then I will have 4 sequences: x of 0, x of 1, x of 2 and x of 3. So we have 4 such sequences, and with this 4 such sequences, now I will have to divide this. So how we will divide it? I will remove or take these 2 samples together. That means x of 0 and x of 2 together, and I will take x of 1 and x of 3 together. Okay, so we will combine and bunch them. So I will have x of 0 and x of 2 together. Then I have x of 1 and x of 3 together. This I called as even part, and this we called as odd part. So I have divided the given sequence into even subpoint and odd subpoint. So previously I was having 4 points. Now I have 2 points even, 2 points odd. Now take these 2 points and add them together. How to add them? Bring x of 2 to x of 0. So I bring x of 2 to x of 0 and I add them at this node. Then I bring x of 0 down to x of 2, but now I negate x of 2. That means I multiply x of 2 by -1. So at this point I am going to get x of 0 plus x of 2, whereas at this point I am going to get x of 0 minus x of 2. Right? Now similarly I do with the bottom sequence, the even part. Here I have x of 1 plus x of 3, whereas here I will negate, and here I will get x of 1 minus x of 3. Okay, so now I got 2 new samples: x of 0 plus x of 2, x of 0 minus x of 2, x of 1 plus x of 3, and x of 1 minus x of 3. Taking this as an input, I will get now 4 inputs: 1, 2, 3 and 4. Right? Now we increase one step. Now I add at this node the first value and the third value. Now I'm going to add the first value and the third value, and then I'm going to add at this junction the second value and the fourth value. Similarly, we are going to bring down and going to negate the third value, and similarly I'll bring here and negate the third value. Okay, so what I did, I added when I go up, when I traverse up ways, that time I'm going to add, and whenever I traverse downside I am going to subtract. Right? Now before actually getting into crisscrosses or into this structure, I will multiply the lower section by 2 factors. one factor is W4 raised to 0 and second factor is W4 raised to 1. Okay, so whenever before entering this sequences, I will multiply the whole sequence by this factor. Let us name this factors as, I name this value as x1, this value as x1 dash, this value as x2, and this value as x2 dash. Okay, so now at the input over here I have x1, I have this as x1 dash, then W4 raised to 0 is nothing but 1, so this value is 1, so 1 multiplied by x2 at this crisscross I am going to get x of 2. What is W4 raised to 1? For that you need to recollect or recall. Let us recall the circle structure of Prudhoe factor. Here we have W4 raised to 0, here we have W4 raised to 1, here we have W4 raised to 2, and here we have W4 raised to 3. This value is 1, this value is minus 1, this value is minus j, this value is j. Right, so I have a W4 raised to 1, which is this, nothing but minus j. So now my x2 is going to multiply it by minus j, and at the crisscross I'm going to get minus j into x2 dash. Right, now whenever you are going to add, I'm going to add now x1 with the third element, that is x2. So this becomes x1 plus x2. Then I'm going to multiply x1 dash with, so I'm going to get x1 dash with this as minus j x2 dash, right? Because that is the factor. Now I'm going to subtract it. So I'm going to get x1 and then minus x2. And here I'm going to get x1 dash minus of minus will give me plus j x2 dash. Agreed? So this is what the complete flow graph looks like. So in a 4-point DFT, this is, we call that the first stage, and this we called as the second stage. Now some books might refer it reverse way. They might refer this as first stage and this as second stage, but I personally believe that this is the first stage and this is the second stage. At the end of this crisscrosses, you are going to get x of 0, x of 1, x of 2 and x of 3. Okay, so if I wanted to finally draw the graph will have 4 lines, 1, 2, 3 and 4. This will always be true. Whatever is the problem, this graph is not going to change. Then I will have x of 0 and x of 2 over here, whereas I will have x of 1 and x of 3 over here. First, at the second stage, we have crisscrosses. So let's say there are 2 crosses, and at the first stage we again have crosses, but then first to third, second to fourth, first to third and second to fourth, with the second lines negated and with a multiplying factor of W4 raised to 0 which is equal to 1 and W4 raised to 1 which is equal to minus j. Okay, so this is the graph of a 4-point DFT. Here I will get x of 0, x of 1, x of 2 and x of 3. So this is my x of n and this is my x of k. So x of k, if you observe, is in order, whereas x of n is not in order. So whenever I say DIT FFT, that time the time sequences are not in order, is off order, and x of k is in order. So I write here that this is in order and this is in decimated order. Fine. So this will always be in order, whereas this will not be in decimated order. Thank you.